Hello, class. Today we are going to be learning about a synthesis of nitrochlorobenzene. But first, we have an educational video to show you the history of this reaction.
The world is changed. Feel it in the solvent. I feel it in the lab. I smell it in the fume hood. Which that once was, is lost. For none now live who remember it. It began with the forging of the great Benzene rings. 3 rings, each with a single substituent, were given to the elves, immortal, wisest, and fairest of all beings. 7 sulfonate rings to the dwarf lords, great miners and craftsmen of the mountain halls. And 9 rings were gifted to the race of men who, above all else, desire resonance. 14 rings was bound the strength and will to govern each race. But they were all of them deceived, for another ring was made. In the land of Mordor, in the fires of Mount Doom, the dark Lord Sauron forged in secret a master ring to direct all others. And into this ring he poured his cruelty, his malice, and his will to direct to Meta. One ring to rule them all. One by one, the subgroups of Middle-earth fell to the power of the ring. But there were some who resisted. A last alliance of men and elves marched against the enemies of Mordor. On the slopes of Mount Doom, they fought for freedom of Middle-earth. Victory was near. The power of the ring could not be undone. It was in this moment, when all hope had faded, that Isildur, son of the king, took up his father's sword. Sauron, the enemy of the free peoples of Middle-earth, was defeated.
Nitrobenzene is formed by reacting nitric acid with sulfuric acid. This protonates the nitric acid into H2NO3, which is extremely unstable. This causes it to break apart into NO2 and H2O, or water. The NO2 plus is a strong electrophile, so this adds to the aromatic ring and forms nitrobenzene. Our Cl plus is formed by reacting AlCl3 with ClCl, or Cl2. The bond is broken, and one chlorine attaches to the AlCl3, producing AlCl4 minus and Cl plus ions. Does anyone in the class know how this adds to the nitrobenzene ring?
Oh, pick me!
Okay, so there are three different ways that the Cl plus can add to the nitrobenzene. It can add either ortho, meta, or para. So the first one I will show you is the ortho formation. So what happens is when ortho, the Cl plus will add to a position directly adjacent to the nitro group. And so what will happen is you will get this product down here. So you get the nitro group with the Cl directly next to it. But there are three different resonance forms of the intermediate along the way to form the product. So there's this one up here, this one here, and this one here. Neither of them are very stable. However, this one up here is the absolute worst of the bunch because it is a plus charge from the nitrogen, right there, directly located next to a plus charge on the benzene ring. And two charges of the same will repel each other, like two positive charges are repelled, so that results in a very unstable structure. And because that is a resonance form, it means that the overall intermediate is less stable. So therefore, the reaction is not likely to go ortho. The meta form is better. So in a meta reaction, the Cl plus will add meta to the nitro group. So that's two positions over the bond there. So this is our product, and the three intermediates that are formed are as follows. So there's this one here, and this one here. So as you can see, there is no resonance form of the intermediate where the positive charge of the nitrogen is directly adjacent to a positive charge on the benzene ring. And this means that overall, a much more stable structure will be formed because there's no direct repelling effect. Therefore, meta is so far the most stable of all the different products of nitrochlorobenzene. The para form is very similar to the ortho form, as a matter of fact. So the Cl plus will add directly across on the other side of the benzene ring from the nitro group. It will result in this final product right here. So you can see that the nitro group and the chlorine are directly across from each other on the ring. And these three intermediate resonance forms are very similar to the ortho resonance forms. So as you can see, this one here in the middle is the absolute worst because, again, it has a positive charge on the nitrogen directly located next to a positive charge on the benzene ring. So that structure, similar to the ortho, results in a very unstable repelling force. And that means that the para, similar to the ortho, is not a very stable form because it's got this specific resonance form. So therefore, meta is the major product because all three of its resonance forms are much more stable than the rest of them. So that explains why the nitro group, NO2, is a meta-director. And as such, this product here is expected to be the major one formed in this reaction.